In the upcoming set notations and definitions, we are going to explore some important concepts in set theory, and I will guide you through one step by one step, so there's no need to worry. I know this list looks scary, but no fear, we will go through each topic carefully and I will make everything clear as we go through. Equal sets are sets that contain exactly the same elements no matter the order. Formally, two sets A and B are considered equal if every element in A is in B and every element of B is in A. This is simply denoted as A equal to B. For example, if we have set A equal to set of 1, 2, and 3, and set B equal to set of 3, 2, and 1, since both set A and B contain the exact same elements, even though the order is different, we can still say that A equal to B. In other words, the order does not matter. The order of elements in the set does not affect whether the sets are equal. Additionally, duplicates do not count in set. Even if we write set A equal to 1, 2, 2, and 3, it is actually the same as 1, 2, and 3 because the duplicate element doesn't affect the equality. It is the unique elements that matters when comparing set. The universal set denoted by this symbol, which looks a bit like an E, is a set that contains all possible elements relevant to a particular discussion or problem. It's like the biggest set you can work with, encompassing everything that you are considering. Think of the universal set as a supermarket that has every item you could possibly buy. Any list of items that you want to purchase will be a smaller set taken from this universal set. The small set can be simply apple, mango, or peach, for example. The universal set is important because it provides a context for whatever you are discussing. For example, if you're talking about natural numbers, the universal set will include all natural numbers. But if you're talking about fruits, the universal set will consist of all kinds of fruits. So the universal set always depends on the context of the problem that you're working with. Let's consider a school as our context. The universal set in this case will include all students in the school. This means every single student from all levels and classes is part of this universal set. Now we can define a subset of this universal set, such as C equal to a set of secondary 4 students. This subset includes only the students in secondary 4 classes, which is a smaller group within the entire student population. In this example, the universal set represents the whole school, while the subset represents a specific group within the school. This is a practical way to show how we can use set in our daily life. The universal set gives us a context, in this case, all students in the school, and subset help us to focus on a particular group or category within the same context. Now let's apply the universal set to a mathematical question. As mentioned earlier, the universal set includes all possible elements within a given context. In this example, the universal set is defined as x, where x is more than and bigger than 1 and x is more than or equal to 20. This means that the set universal set includes all the integer x, where x is between 1 and 20 inclusive. That means the universal set includes number 1, 2, 3, 4, 5 all the way to 20. And then set A in this example is a specific set that is defined using a condition that the elements must satisfy. In this case, set A is defined as x, where x is a multiple of 5. This means set A includes all elements from the universal set that are multiples of 5. We can explicitly list set A by enumerating all the elements. Therefore, we can put set A as open curly bracket 5, 10, 15, and 20. Listing the elements directly show that the set A includes a multiple of 5 from the universal set.